Let us discuss about discharging of a capacitor. Say we are given with a capacitor on which the charge is already given, that is plus Q and minus Q on two of its plates. And say if the two plates of capacitor are connected via switch, and if we close down the switch at t equal to 0, we can see if the high potential plate and low potential plate are connected together, obviously the charge will get neutralized till the potential becomes equal, and the final potential of capacitor will become 0 on both the plates, or its final potential difference 0 and final charge will also be 0. In this situation, as in the connecting wires there is no resistance connected, the process will be very quick or fast. If we just plot the variation curve for discharging, that is for charge as a function of time, then prior to t equal to 0, we can see that charge on capacitor was Q, and as soon as the switch is closed, suddenly the charge will get discharged and the value of current will be excessively high and it will suddenly drop down to 0. Or we can say this transient duration delta t will be tending to 0 as the wires considered here are perfectly conducting. And the similar situation we can see when a resistance is present in the circuit. See, the situation is like this. The capacitor is having a charge plus Q and minus Q, and a resistance is also present over here, and now the switch is closed at t equal to 0. Again, the charge will have a tendency to discharge through the switch and the resistance, but due to the presence of resistance, the process will be slowed down, or you can say the value of current will be relatively less in this situation, so the complete discharging process will take relatively a longer time. And if we plot the curve of the discharging process, again the situation is like this, that before t equals to 0 charge was Q, and now it will gradually start discharging like this, and finally it will be asymptotic down to the time axis. And here again, if we increase the value of R to R prime, where R prime is more than R, then we can say if resistance is increased, current will be further decreased and the process will be much more slower. And we can see the slope of graph will be relatively very less, and it will take much longer time to be decreased down to 0. So if this is the curve for resistance R, this will be for R prime, where we can write that R prime will be more than R. And certainly if you decrease the value of resistance, it will be in a quick drop, like the charge will drop down to 0 relatively in a shorter period of time. And now in the next section we are going to analyze mathematically this complete process of discharging as well as its transient analysis.